Prediction of surface roughness of an abrasive water jet cut using an artificial neural network. In this presentation, our goal is to offer you a quick summary of the research and conclusions. Please follow the links to review the research in further details. Thanks to all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share, and subscribe. The study's primary purpose was to explore the abrasive water jet, or AWJ, cut machinability of stainless steel. The study analyzed the effects of such process parameters as the traverse speed, the depth of the cut, and the abrasive mass flow rate, or AR, on the surface roughness, or RA, concerning the thickness of the workpiece. 3 different thicknesses were cut under different conditions. The surface roughness was measured at the top, in the middle, and at the bottom of the cut. Experimental results were used in the developed feed-forward artificial neural network, or ANN, to predict the surface roughness. The ANN's model was validated using k-fold cross-validation. The lowest test root mean squared error of 0.2084 was achieved. The results of the predicted surface roughness by the ANN model and the results of the experimental data were compared. Additionally, as traverse speed and depth of the cut were recognized, analysis of variance at 95% confidence level were used to determine the most significant factors. In summary, this study's novelty consisted in its introduction to the ANN's method as a useful tool for predicting surface roughness along the entire depth of the cut at AWJ cutting of the stainless steel and different thicknesses. Its main benefit is the reduced time needed for experimenting.